We are chapter 1, section 4. What's the learning target for today? Distance and slope. That is the learning target for today. Distance and slope. Let's take a look at the distance formula today. First, start off, and I know we can take a look up on a poster board here, and our distance formula is right here. All right? What does this distance formula look like? Doesn't look like anything when I draw with that. Distance equals the square root of x1 minus x2. Doesn't matter. Doesn't matter. And I'm going to show you why it doesn't matter which order we have these in as long as they're consistent. Why? Yes, I do. No, you don't. So I'm going to have to show you. I2 squared. Okay. What's that? All right. If I subtract from one end to the other and it's positive, or I go the other way from this end to this one and make it negative, when I square it, what happens? It becomes positive anyway, right? So it doesn't matter if you put x1 before x2 or y1 before y2 or the other way around on the distance formula. You can do it either way. All right? Now, what does this equation start to look like to you? What does it start to look like to you? Pythagorean theorem.
No, not at all.
Watch what happens. I can square both sides, right? And I can make a d squared equals x1 minus x2 squared plus y1 minus y2 squared. If I would have just made these x, let's say make this x1 and make this, or make it x and y, I should say. Let's get rid of that. Then I can say d squared equals x squared plus y squared. Does that look like the Pythagorean theorem? I'm just telling you, there's a relationship between the Pythagorean theorem and a distance formula. Confusing you about what? I haven't started on anything yet. What is it? This one or that one? Where's the distance formula? What does the distance formula tell you to do? I'm showing you the relationship. No, it's really not. Because as you learn more it's not irrelevant, because as you learn more in pre-calc, you're going to learn how to derive different things from different formulas. Yes, Maddie? Well, in a distance formula, if you're finding a distance between two coordinate points, what are you going to use? You can't use the Pythagorean theorem as it sits, but we can derive... You just marked absent. Right here, all I'm telling you is if I have to find the distance, I can use the Pythagorean theorem to derive the distance formula. Okay? That's what I'm trying to say. There is a correlation between the two. And as you get into this more and more, you're going to learn how to derive stuff. This is where you guys become powerful, all right? This isn't algebra. This isn't geometry. It isn't algebra 2 where things are given to you all the time. When you guys really become powerful with mathematics is when you can derive from things you already know, all right? And this is a start. I'm just showing you that a distance formula is very similar to the Pythagorean theorem. You can derive from it. Okay, so we've got our distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. We have our distance formula. What do we have in there? We're going to have two different coordinates points. I'm going to call coordinate A, let's call it 3, 4, and coordinate B, which is, let's say, negative 1, 6. If you take a look at a coordinate like this, and we plot this out, 1, 2, 3, 1, 2, 3, 4. Let's say this point is sitting right here. This is A. And then we plot out B, negative 1, up 6. It's somewhere up here. This is B. What is the distance between these 2 points? We know that this is x1 and this is x2. Can we switch those around? Call this x2 and this x1? Yeah, we can. Here's y1 and here's y2. We can plug that into the equation and we can figure that out. All right, we plug this in. We have the square root. We have the distance of these two. The distance equals the square root of 3 minus a minus 1 squared plus 4 minus 6 squared, which equals square root 3 minus a minus 1, 4 squared, 16, plus negative 2 squared is 4, square root of 20. Square root of 20. What's the square root of 20? If I had to guesstimate where it was. How do you do it? You could do... Yeah. It's like 4.5. Why would you say 4.5? Because if I look at a number line here, and here's 20. You're being a bummer. There's 20. 25 is over here, the other square, and over here is 16. It falls somewhere in between. It's right around 4.5. We know the square root of 16 is 4. We know the square root of 25 is 5. Falls somewhere in between there, around 4.5. Okay? Good job. Slope formula. Have you guys worked with a slope formula before? So you're rocking. You know the slope formula. Slope formula, y1 minus y2 over x1 minus x2. Does it matter if I have y2 in front and x2 in front? Why not? Because the signs will be consistent. Let's say this becomes a negative on top, but this is a plus on the bottom. If I switch these two around, all right, then maybe my plus would be on the top, my minus would be on the bottom. Either way, you're going to come up with the same sign, so it doesn't matter. As long as you do the ones first and then twos, or the twos first and then the ones. You got to be consistent on it. You can come up with a slope on it. Okay, center point. I don't need this. All right, center point. What is the center point between 2 points. You guys seen this before? Have you? Center point between 2 points. So I'm giving you a coordinate A as 2, 3, and a coordinate B as -4, -6. And I want to find my center point between them. All right? This is going to be an important one. Why would we divide by 2? There's 2 points each coordinate, right? So I'm going to go 2 minus a -4, which is a +4, and 3 minus a -6, which is a +6 on those points. X's, these are my X's, these are my Y's. These are my X's, these are my Y's. And I can come up with my center point. What's my center point on this? 3? Yeah, I suppose it is 3, isn't it? No. Three and what? 4.5? 4.5? There's my center point. You guys good with that? It's good. Let's do (17 through 21) odds. This is page 34. Bless you. Let's do 17 through 31 odds. That's your assignment for today.